How might the coming climate crises change the way we teach economics? Using the Green Business Lab to help students connect the dots. I'm Becky Haney, Associate Professor and Chair of Economics at Calvin University. My co-authors are Matt Heun, Professor of Engineering at Calvin University, and Samantha Svboda. She's the creator of the Green Business Lab. In response to looming economic, social, and ecological crises, it is reasonable to ask, how might the coming climate crises change the way we teach economics? In a review of climate change content across introductory economics texts, famous stand-up economist Jorn Bauman and his co-authors argue that issues of climate change need more prominence in economics education, and that there should be deeper interdisciplinary ties between economics and other perspectives. That paper, as well as this one, were both inspired by Robert Shiller's 2010 JEE article, How Might the Financial Crisis Change the Way We Teach Economics? This is not just a theoretical exercise. Just last week, a landmark case in The Hague established a precedent that firms must comply with climate accords similar to the countries they are located in. The district court in The Hague on Wednesday ruled that Royal Dutch Shell is partially responsible for climate change and must reduce its carbon emissions by 45% by 2030, compared with 2019 levels. Firms are increasingly being held responsible for the life cycle of their product. This case provided an additional wake-up call. The court ruled that Shell is responsible for emissions from its customers and suppliers, known as Scope 3 emissions. That is, firms are responsible for emissions over the entire product's life cycle, cradle to grave, so to speak. Indeed, the concerns are not just environmental, but social. The court stated that Shell's activities constituted a threat to the right to life and undisturbed family life as set out in the European Convention on Human Rights. This system diagram helps explain how deeply intertwined the economy is with ecological and social systems as well. Economic texts often treat the economy as a self-contained system, separate from other systems. But this does not equip students to understand the true economic realities, let alone understand the challenges that climate change creates. Discussions of climate change simply as an application of Pigovian taxes is not enough. Bringing climate change more fully into economic education is necessary, but not easy. Economic analysis, performed within the context of climate change, requires an interdisciplinary approach. Economics content related to investment in human-built capital and marginal thinking and opportunity costs must be coupled with content from the natural sciences to understand aspects of natural capital, such as energy efficiency, ecological impacts, and climate science, and also connected to other social sciences to understand aspects of social capital and institutions, as well as engage issues around disproportionate global environmental impacts from the economy. Because of the economic impacts of climate change, economic analysis is becoming increasingly subject to ESG, or environmental, social, and governance criteria. In May 2021, 2 new Exxon board members were elected to, quote, to force the company's leadership to adjust its business strategy to match global efforts to combat climate change. The immediate response was positive. Exxon shares rose 1.2% that day. This presentation demonstrates how we use the Green Business Lab to teach economics while remaining in conversation with other disciplines. The Green Business Lab is team-based, interdisciplinary, and an extended simulation. It takes place over several class periods, and the students have time to explore the relationships between firms, the economy, and the environment. What we're going for is less teaching and more learning. Instructors are guides on the side, and we facilitate class-wide reflection and analysis. In this presentation, I'll describe the simulation from the student and instructor perspectives, its learning objectives, and assessment. The paper provides further review of the literature around team-based learning simulations and interdisciplinary curricula, and the appendices in the paper contain supplementary teaching notes and materials for the lab itself. One of the most important attributes of interdisciplinary curriculum is that it provides an overarching framework or roadmap that connects ideas for students. An ongoing, consistent framework allows students to engage complex questions from within. They learn how to apply disciplinary knowledge content and also how to ask questions to gain additional perspectives and connect to other disciplines. Our approach to teaching economics with climate change in the foreground is to use the Green Business Lab as the through line to enable students to learn economics while in conversation with energy, climate science, and other disciplines. Because the Green Business Lab is an extended simulation, it allows students to dive deep into a realistic problem. This motivates them to learn and to apply knowledge content. Extended simulations give teams several class periods to work through the problems, address questions and challenges that arise in a realistic situation. The lab itself is based on realistic problems, those that have unclear goals, multiple solution paths, and uncertain evaluation criteria. The extended nature of the simulation gives students time to wrestle with these complex problems and develop skills and knowledge content required for engaging them. As I mentioned, the Green Business Lab is team-based. Students apply knowledge content to real-world challenges, and instructors observe the interactions between the students and listen to their rationale. The instructors help students frame the complex problems and provide guidance on the side. The context for the Green Business Lab is a fictional, relatable industry in the transportation sector. The transportation sector is essential to climate change. And the lab uses real-world situations and examples from multiple industries. Thus, the lessons that are learned in the lab readily apply to any industry. One of the most realistic and attractive aspects of the lab is that it involves a physical product. Students design, manufacture, and test the performance of a physical prototype using Connect's components and ping pong balls, called spheres, in the lab. So the students design, manufacture, and market a SphereMover using identical kits of materials provided by the lab. Students compete against each other for market share in a simulated market, and then students practice for one cycle and then go through this process 3 more times for 3 business cycles. Even though the components in the kit are simple plastic parts, they represent complex components made of multiple materials, such as metals, plastics, biological materials, and ceramics. The students are immersed inside a firm to explore the theory of the firm. Students make decisions from the perspective of the firm or managers in the firm and learn how to evaluate opportunity costs, make trade-offs, optimize customer, employee, and stakeholder perspectives, and experiment to understand the impact of economic decisions. They take on a managerial role in either marketing or manufacturing, and they communicate with their CEO through emails. They also communicate with external stakeholders, including customers, suppliers, nonprofit organizations, government representatives, communities, etc. Students analyze data to make their design decisions. They use detailed cost and environmental impact data tables like these to analyze their options and make trade-offs over all 5 of the life cycle stages. The lab is centered on the economic and environmental impact of the product design. Each of the components short red rods, long blue rods, white connectors, small wheels, etc., has simulated economic, energy, pollution, and social impacts. For example, in comparison to red rods, blue rods have lower direct costs and lower energy use, allowing for a lower price, higher profits, and lower environmental impact. So initially, it makes sense to choose blue rods for the design, right? But not so fast. For consumers, red rods are must-have components. Must-have components are analogous to customer preferences, such as preferring leather over recycled plastic car seats. Thus, the decision over which rod to use is an optimization problem that must take into account customer demand and other multiple perspectives. The product lifecycle framework, an approach, is what brings climate change front and center to the economic content. Most economic education centers on the environmental impact of the customer use or end of life disposal of a product. The lab helps students develop a more comprehensive awareness of the relationship between economic and environmental systems by including all 5 product life stages. Student teams are responsible for pollution impact and energy consumption across all 5 life cycle stages: raw material extraction, manufacturing, distribution, customer use, and end of life. Some life cycle costs are internalized. When appropriate, costs are charged to the company, such as a manufacturing waste disposal fee or energy cost from distribution. Energy savings in manufacturing reduces costs on the income statement. Environmental regulations may limit the pollution made during the raw materials life cycle stage or may require the firm to take action. However, some life cycle costs are externalities. The cost or impact of pollution, such as carbon emissions, smog, plastic packaging dumped in the ocean, is not paid by any company or supplier, but the impact is carried by the society as a whole. Society as a whole does have representatives. The Green Business Lab introduces students to stakeholder theory. This increases the interdisciplinary aspect of the simulation. Students get real-time assignments and feedback from their CEO, and they can communicate by email with internal and external stakeholders. So the business interests and the stakeholder interests form a shared value in the lab. The CEO and other stakeholders require the teams to grapple with how to account for external costs, and they send suggestions to consider. From the student's perspective, the online component of the simulation appears to be a self-contained company, and these direct communications add realistic context to their economic decisions. Thus, the students receive live, dynamic feedback from within the world of the situation, of the simulation, as well as feedback from the instructor. The lab gives students experience with making economic decisions using ESG criteria as constraints. Economic decisions affect environmental and social areas at each life cycle stage. Students decide which components to use and whether to use new, remanufactured, or recycled. They evaluate product take-back alternatives. The key vehicle that allows students to connect the dots between economics and climate change is through evaluating the environmental and social impacts at each life cycle stage of their product. All of the decisions provided in the lab are based on real-world scenarios, and students are giving links to suggested readings for more information. One of the first decisions students decide is where to locate their factory, in either an industrialized nation or developing nations. They are immediately confronted with the relationship between the economy, environment, and society. Manufacturing operations in the developing nations cost less, but produce greater environmental impact, pay lower wages, and have fewer regulations regarding worker safety. So students are choosing between industrialized and developing nations at a variety of places, not only where to locate the company, but also where to assemble and distribute, where to source their raw materials and their intermediate goods, and which consumer market to sell in. Economic analysis using the ESG criteria shows up throughout the lab. They have multiple opportunities to evaluate economic decisions. In fact, the simulated company has active board members, like those that were recently elected to the board of Exxon. The board members and other stakeholders provide the teams with several investment scenarios to consider each business cycle. Each investment scenario involves trade-offs. Some of the trade-offs are easily quantifiable. The lab tracks pollution emitted and energy used for each of the 5 life cycle stages of the SphereMover. Other costs and benefits are more subjective, such as the impacts on worker safety at a manufacturing plant located across the globe in a developing nation. These decision-making challenges give students opportunities to engage economic content from multiple perspectives. Students are guided in the lab through 4 experiential learning stages. The first one, they experience the lab. They apply course concepts and personal knowledge to practice decision-making. Second, they reflect. They think about performance results, they discuss the experience with other students, and they get feedback along the way from the professors. Third, they process. They reason through new ideas to develop them, change behavior, and improve. And fourth, apply. They act on the new insights by trying them out in the next cycle. And the cycle repeats. Opportunities for learning and reflection come at natural breakpoints in the simulation. The simulation entails 3 business cycles where each cycle culminates in the companies competing against each other in the simulated market. The market results are available to students the next day. And then guided class-wide discussions to analyze the overall market results are opportunities for students to make the meta-connections between economics and climate impacts. The learning objectives we had for the Green Business Lab section of the course were to 1, understand how consumer preferences both constrain and encourage low environmental impact and socially responsible managerial decisions. And 2, to understand what incentives profit-maximizing firms have in order to reduce environmental impact and enhance social outcomes along all 5 stages of their product lifecycle. Formative and summative assessment. There were plenty of opportunities in the lab for formative assessment. One of the key places for us was at the end of the business cycle, the student teams worked together to work on answers to debrief reports that they were preparing for their CEO. Within the lab, though, the instructors are able to read those debrief reports and score them and give pointed feedback, targeted feedback back to the students. And those prompts in those debrief reports could also be customized. So 2 of the example prompts we used are here on the slide. Some of the life cycle impacts are not connected to company financials, but are externalities borne by society. For example, pollution impact from raw materials or pollution impact during customer use. Was the team aware of this? What did you think about it? We got some really interesting feedback on those, and how many students mentioned that their eyes were opened quite a bit through the lab in seeing how much a product can impact the environment, not just from their own use of it or disposal of it. And then another prompt we used. After seeing other companies' presentations about how they prioritized projects, would you change your approach if you were going to do this again? And again, this was an opportunity for students to learn from each other and for us to see how they were processing and how were they applying or not the economic knowledge content that we were hoping for. Again, these were opportunities for formative assessment. And for summative assessment, we added some essay questions on our final exam to talk about some of the connections between the economic content and other perspectives. The overall experience with the Green Business Lab is fun. You're working with a physical product, so it's fun and engaging for the students and the instructors. Students learn through the experience of evaluating their own and other student companies' performance. Some onboarding is required for students and instructors, but the lab has 3 levels of engagement, each with different time commitments. The lab is customizable, and it can be targeted for undergraduate or graduate level students. And the lab comes with a significant amount of scaffolding. There's participant and instructor guides, dashboards, video tutorials. So, to recap, how might the coming climate crises change the way we teach economics? One tool we have found useful is the Green Business Lab. It's team-based, it's interdisciplinary, and it's an extended simulation. It comes with a lot of scaffolding, and it's a lot of fun. It helped us get to less teaching and more learning in the classroom. If you want to know more about the Green Business Lab or would like to request a demo, the website address is at the bottom of the slide, gblsim.com. Thank you.